Welcome back. We are nearing the end of the remedial journey. We have remaining rare but critical defects, the trivial many defects, resistance to change, and holding the gains. The worst defects are those involving human safety and health. For such defects, society has become intolerant. In personal injury lawsuits, the rule is now strict liability. This intolerance is being extended to other classes of defects. For some products, the tolerable levels of defects are now expressed in terms of parts per million, ppm, instead of percent, or parts per hundred. An example is electronic components for assembly into computers or color television sets. Our traditional quality planning has been good enough to bring defect levels into the range of parts per hundred, but not good enough for attaining levels of parts per million. To reach levels of parts per million, we must go beyond the traditional approach. In part, this means updated technology, automated processes, automated testing. But it also requires wider use of the quality sciences and disciplines. We saw many examples in the last two sessions while discussing systematic remedies. These remedies demand front-end investment in such forms as deeper analysis of symptoms or extensive tests of theories of causes, as in the piston ring case. In the piston ring case, the investment was mainly in analysis. Or we may make investment in other departures from the ways of the past. Yet we must make these investments if we are to attain parts per million levels. Let's also notice that some past practices have become non-solutions if we need to get down to parts per million. First, the sampling fallacy. A widespread practice is to take samples from the product. Then, based on the results of the sampling, we accept the good lots and sort the bad lots. We can simulate with a bead box. The bead box contains 1,000 beads. Of these, 10, or 1%, are blue. The blue beads will be our defects. There are 100 holes in the paddle. We can easily take a sample of 100 and count the defects in the sample. Now let's take a series of samples and tally the results. We have 1, 2 in the sample. Let's make a data sheet. This time we have none. Again, we have none. That's 1. Again, 1. We'll try just one more. And none. We see that the number of defects in the sample varies, despite the fact that the lot remains the same. It always contains 1% defects. Now suppose we set up a sampling plan. Take a sample of 100. If there are no defects, the lot is good, hence we ship it. If the sample contains one or more defects, the lot is bad, hence we sort it. We would ship some lots and sort others, yet the lots are really all alike. Those lots which showed no defects in the sample were just lucky. A further limitation to sampling is the size of sample demanded. At parts per million levels, the sample sizes can run to hundreds of thousands of units. The sample sizes become equal to the lot sizes, so sampling becomes academic. Another fallacy is the belief that if inspectors sort product, they find all the defects. Actually, human inspectors are quite fallible. They find about 80% of the defects present. They fail to find the remaining 20%. As a result, if we are forced to sort product to remove critical defects, we must use non-human methods of sorting. Next, let's look at the problem of the trivial many defects. In our earlier sessions, we purposely chose projects from the vital few as disclosed by the Pareto analysis. We deliberately ignored the trivial many defects because they collectively accounted for only a minority of the costs of poor quality. This model shows what happens when we carry out a successful attack on the vital few defect types. Let's say we have 500 defect types in our list. We conduct the Pareto analysis and discover that 50 of those types account for 2/3 of the cost of poor quality. Next, we assign managers and engineers to tackle these 50 vital few defects. We make a big reduction in the cost of poor quality. We have a successful program. So far, so good. Now, what about the residue from the 50 vital few defects? What about the 450 trivial many, which we did not tackle? There are two approaches. First, attack on these trivial many collectively. And second, attack on the trivial many individually. The collective approach is feasible if we can find some commonality among the trivial many. For example, the same basic process is used to make numerous catalog items which differ from each other relative to some common quality characteristic. In the watch factory, there were many sizes and shapes of shafts, but one common lathe process made all of them. Similarly, the same chemical process turns out many colors of paint. The same electrochemical process turns out many catalog items of large-scale integrated circuits. The same concept is valid for office operations. In the job shop, the order editing errors are a major source of product defects. These defects are of multiple types, each being a member of the trivial many. However, the order editing process may qualify as a member of the vital few. How about attacking the trivial many individually? Until the late 1970s, the West had no way to do this. The only problem solvers were the managers and engineers. The companies could not justify spending the time of engineers and managers to tackle the trivial many on an individual basis. In contrast, the Japanese do have a solution. Ever since 1962, they have trained millions of workers in problem solving. Teams of these workers, called QC circles, have since 1962 tackled and solved literally millions of trivial many problems. Our model shows how these circles go beyond the results attained by the managers and engineers. Starting in the late 1970s, companies in the West began to experiment with the QC circle concept. Whether this concept can take root and flourish in the West will not be known with confidence until the late 1980s. Meanwhile, let us notice a trap into which some companies have fallen. They have gone into the QC circle concept in the hopes of solving the company's quality problems. They may well make progress on the trivial many problems. In doing so, they are failing to make progress on the vital few problems. They should tackle first things first. Now, let's look at resistance to change. On the face of it, diagnosis and remedy are technological problems. Once we have found the cause and designed the remedy, the rest should be easy. Just apply the remedy. Instead, we run into another severe obstacle. We call it resistance to change. The resistance comes from various sources: managers, supervisors, engineers, the union, the workforce. What is common is the puzzling reasons given for the resistance. From a technological standpoint, these reasons are illogical and even senseless. Sometimes the resistance comes from the very people the change is intended to benefit. What is behind all this? When we dig in, we discover we are dealing with two changes: a technological change and a social consequence of the technological change. The social consequence is the troublemaker. It is an uninvited guest which rides in on the back of any technological change. Accordingly, to understand resistance to change, we must first understand the nature of this social consequence. Who can provide us with such understanding? Not the managers and engineers. They are amateurs in such matters. The experts, if any, are the behavioral scientists and especially the cultural anthropologists. The cultural anthropologists carry out studies of human societies. A society is a continuing body of human beings engaged in common purposes. The natives in a South Seas island village are a society. So are the melters in a foundry. A major finding by the cultural anthropologists is that all societies, without exception, evolve a pattern of culture. A tightly woven system of habits, status, beliefs, traditions, practices. This cultural pattern arises as a response to some real needs, for example, to establish law and order. Once it has been evolved, the cultural pattern is then perpetuated by learning. New members of the society, a new child born into the village, a new recruit hired into the foundry, all are taught what is the accepted pattern of behavior. The new members also learn that unless they comply with this pattern, life can become quite unpleasant. So the cultural pattern serves as a vital stabilizer to any society. Hence, the society will resist technological changes until they have been examined to see what threats they pose to the stability of the society. This resistance extends to beneficial changes, since such changes may also require a price to be paid in cultural values. All of this is important to the remedial journey. The advocates of improvement must, as part of their planning, answer the question, what threats does this change pose to the cultural pattern of this society? Unfortunately, many of our advocates of change are not even aware of the existence of cultural resistance, let alone its detailed makeup. Our engineering schools seldom provide training in such matters. Most of our companies are not very helpful either. So our advocates must learn by experience. In time, they do learn, but during the learning process, their mistakes are a source of damage to all, including the advocates themselves. Our companies can reduce this damage by training early in the career of the advocates for change. Now let's go back to that question: what threats does this change pose to the cultural pattern? A major input for identifying these threats is members of the society. They give reasons for their resistance. These are a mixture of stated reasons and real reasons, a mixture of noise and signal. For example, early in the 20th century, the railroads changed from coal-burning locomotives to diesels. This was a technological change, but it had a social consequence. It eliminated the need for the locomotive firemen. The firemen put up a savage resistance. Their stated reasons were those of public safety. Their real reasons were clearly the loss of their jobs and status. They enlisted enough support to remain on the job in the diesels. Many present-day cases parallel that of the locomotive firemen. A project to improve worker productivity may threaten the jobs of some workers. The threat may apply to the supervisors instead. For example, we are discussing a proposal to train production workers in self-inspection. If successful, the result would be to eliminate the work of 7 full-time inspectors. Instead, there would remain 2 full-time auditors to audit the inspection done by the production workers. Now the supervisor of those full-time inspectors resists the change and offers many plausible reasons. The one reason not offered is, this change would make my job less important. Some real reasons are well hidden. In that watch factory, there was prompt agreement that the lathe department should be provided with gauges of greater precision. Yet it took 6 months to do so. The reason for the delay was the wounded pride of the managers. Years before, they had designed and built their own dial gauges. They thought that because they were experts at measuring time, they must also be experts at measuring distance. It took them 6 months to swallow their pride. Only then did they buy dial gauges from the real experts, from companies in the gauge business. The pattern of culture may be so tightly woven that it rejects new truths. It is too difficult to pull out the outworn beliefs. During the 14th century, some astronomers contended that contrary to old beliefs, the Earth revolves around the sun. Their proofs were technologically impressive. Yet the citizenry did not give up their old beliefs. These beliefs had come down from religious books, revered teachers, ancestors. These same beliefs were reinforced by one's own senses. They could see the sun moving around the Earth. So the new beliefs could not be accepted. It was too difficult to pull out the old beliefs. It was easier to burn the astronomers. All that talk about cultural patterns is educational, but practical managers want to know what specific actions should we take in order to deal with resistance to change. Here, the anthropologists have been quite helpful. They've spelled out the rules of the road. Provide participation. Members of the culture should participate both in the planning and the execution of the change. Recall that foundry manager in the piston ring scrap project. He was active in steering the project, reviewing data, theorizing, challenging the findings. That was participation in the planning. Then, as the causes became evident, he took the initiative for remedial action. Now suppose that the engineers had made that study without the participation of the foundry manager. What would have been his reaction to proposals to enlarge the spouts, clean the spouts, etc.? Under this supposition, it was not his plan. He had not participated in the planning. He would tend to regard the proposals as a form of medicine offered by aliens. He's asked to say, ah, so the medicine can go and cure the ailments. His resentment at being excluded would jeopardize the entire project irrespective of the technological merits. A second rule of the road is to provide enough time for members of the culture to evaluate the merits of the change in relation to the threats and find an accommodation with the advocates of the change. Sometimes the threat is so severe that no accommodation is found during the lifetime of an entire generation. Such was the case with the locomotive firemen and with the earth-centered believers. At one time, there were two theories of the nature of light, the corpuscular theory and the wave theory. The corpuscular theory was the most popular. Today, the wave theory dominates. In the words of James Clerk Maxwell, we used to believe in the corpuscular theory. Now we believe in the wave theory because all those who believed in the corpuscular theory have died. With the watch factory managers, it was different. The proposal to buy gauges was a blow to their pride, but they did want the benefits of greater precision. So, after taking 6 months to swallow their pride, they did adopt the proposal. Clearly, introducing change into a culture is not simple, not like throwing a switch and presto change. Instead, we are dealing with biological processes. They have their own pace, deliberate, majestic. It is well illustrated by the incubation of the chick. It takes 21 days for a hen's egg to hatch out into a chick. Thousands of years ago, it also took 21 days. Some people resent that. No progress. Look at travel. We've gone from the ox cart to jet airplanes. That's progress. But the stupid chicken still takes 21 days. Well, here are some eggs incubating. Why not take a Bunsen burner and apply it? Let's go. So we get hard-boiled eggs. Robert Wilhelm Bunsen would hardly recognize this jumbo device. Here's a supervisor who resists change. If we apply a Bunsen burner to him, we again get an unexpected result. There are multiple ways to provide time to enable the members of the culture to accommodate to the change. Start small. A small-scale tryout reduces the risks for all concerned. Avoid surprises. A major benefit of the cultural pattern is predictability. A surprise is a shock to predictability, a disturber of the peace. And choose the right year for introducing the change. There are also other rules of the road. Omit excess baggage. Don't clutter up the proposals with side issues. We may end up debating the side issues instead of the main subject. Work with the recognized leadership of the culture. The culture has its own leadership, and this is often informal. Convincing the leadership is a long step toward convincing the culture. Treat the people with dignity. The classic case was that of the relay assemblers in the Hawthorne experiments. Their productivity kept rising under good illumination or poor, because in the laboratory they were being treated with dignity. Reverse the positions. Use role-playing to bring out what would be my position if I were a member of the culture. Deal directly with the resistance. There are various options. Try persuasion. Or offer a quid pro quo, some concession, in return for some acceptance. Or change the proposals so as to meet specific objections. Or change the social climate so as to make the proposal more acceptable. Or forget it. No company is able to get 100% of its proposals adopted. Now, let's look back at the high points of this session. Society has become intolerant of safety-oriented defects, no matter how rare. Even for non-safety-oriented defects, the trend is to establish tolerable levels in parts per million. Traditional quality planning is able to bring defects down to levels of parts per 100, but not down to parts per million levels. To get down to parts per million levels requires intensive application of the quality sciences or disciplines. For rare defects, there's no longer any solution through sampling to separate good lots from bad or through 100% human inspection. The trivial many defects can be tackled economically as projects provided that they exhibit some commonality of origin. In the West, it is not economic for managers and engineers to tackle the trivial many defects on an individual basis. In Japan, it is economic for the workforce to tackle the trivial many defects on an individual basis. Every change consists of two changes: a technological change and the social consequence. The social consequence is the troublemaker. Industrial organizations are also human societies which evolve patterns of culture. The impact of the technological change on the cultural pattern is what creates the social consequence. The company's advocates of change should be trained in how to evaluate the impact of the proposed changes on the cultural pattern. The advocates of change should learn the rules of the road for dealing with the culture, principally provide participation and provide enough time. Finally, between now and the next session, look back over earlier projects in the company. Did the advocates of change know of the existence of the cultural patterns in the area under study? Did they evaluate the impact of their proposals on the cultural pattern? Did the advocates make use of those rules of the road for dealing with the culture? With respect to your present project, examine the nature of the resistance encountered to the proposed changes. Distinguish between the stated reasons and the real reasons, and determine what are the applicable rules of the road. Also, read the workbook notes for session 15. Good luck.